In this session, we will be solving the last exercise, that is exercise 1.4 from NCERT exemplar. The first question is, show that the cube of a positive integer is of the form 6q plus r. Q is an integer and r equal to 0, 1, 2, 3, 4 and 5 is also of the form 6m plus r. Like in the previous videos we have seen, we will solve this question by using Euclid's division lemma. Let's apply Euclid's division lemma to a and b equal to 6. We get unique integers q and r satisfying a equal to 6q plus r, where 0 less than or equal to r less than 6. Therefore, possible values of r will be 0, 1, 2, 3, 4 and 5. When r equal to 0, then a will be equal to 6q. When you cube on both sides, we are cubing it because they are asked in the question cube of positive integer. When you cube this, it becomes a cube, which is equal to 6q whole cube. And we know that 6q whole cube is 216 q cube. This can be expressed as 6 times of 36 q cube. So this is like some 6m plus 0. Same way, when r value is taken 1, we have a equal to 6q plus 1. Cubing on both the sides becomes a cube equal to 6q plus 1 whole cube. If you cube this by expanding, we get a cube value as 216 q cube plus 108 q square plus 18 cube plus 1. In the first 3 terms, I can take 6 common. I'll be getting 6 times of 36 q cube plus 18 q square plus 3 cube added to 1. This implies this a cube is in the form of 6m plus 1. If you consider r value as 2, then a will be 6q plus 2. If you cube on both the sides, we get a cube as 6q plus 2 whole cube. On expanding, it becomes 216 q cube plus 216 q square plus 72q plus 8. This 8 I'll write as 6 plus 2 so that I can take 6 as common, and it becomes 36q cube plus 36q square plus 12q plus 1 plus 2. So it is something like 6m plus 2 format. If you consider r value as 3, we get a equal to 6q plus 3. On cubing both the sides, I get a cube as 216q cube plus 324q square plus 162q plus 27. This 27 can be written as 24 plus 3, so that 6 can be taken common, and we get 6 times of 36q square plus 36q cube plus 54q square plus 27q plus 4 plus 3 is like 6m plus 3 form. Now if you take r value as 4, a becomes 6q plus 4. Now you cube on both the sides to get a cube equal to 216q cube plus 432q square plus 288q plus 64. This 64 can be written as 60 plus 4, so that 6 can be taken common. It becomes 36q cube plus 72q square plus 48q plus 10 added to 4. So it is something like 6m plus 4. Same way, when we take r value as 5, we will be getting a as 6q plus 5. A cube will become 216q cube plus 540q square plus 450q plus 125. When 6 is taken common by writing 120 as 120 plus 5, we will be getting 36q cube plus 90q square plus 75q plus 20 added to 5. And this will be same as, this form will be same as 6q plus 5. So every time we get in 6m plus r format, we get in this format. Next we will be solving second and third question together. The reason is, In both the question, we have to solve in the same method, and same answer will suit for both the questions. In the second question, we are asked to prove that one and only one out of n plus 2, n plus 4 is divisible by 3, where n is any positive integer. In the third question, we need to prove that one of 3 consecutive positive integers must be divisible by 3. Like in the previous videos we have seen, we have to apply Euclid's division algorithm. Apply Euclid's division lemma. For n and b equal to 3, there exists unique Q and R satisfying A equal to 3Q plus R, where 0 less than or equal to R less than 3. Here there are 3 possibilities for the value of R. For the possible values of R, 0, 1 and 2. I'll make 3 columns. In each column I'll consider the value of R. That is, in the first column I'll consider when R is equal to 0. In the second column I'll consider when R is equal to 1. In the third column I'll consider when R is equal to 2. Here, since I have taken the number n and b, I have to consider n equal to 3q plus r. When r value is 0, then n will be 3q. When r value is 1, then n will be 3q plus 1. When r value is 2, then n will be 3q plus 2. Now you just observe these 3 formats: n equal to 3q, 3q plus 1 and 3q plus 2. When n value is 3q, it is divisible by 3. When n value is 3q plus 1, it is not divisible by 3. When n value is 3q plus 2, it is not divisible by 3. So you can conclude that out of the 3 formats here, one of these 3 consecutive integers must be divisible by 3. We can conclude here one of 3 consecutive positive integers is divisible by 3. Now let us take n plus 2, because here we have n plus 2 and n plus 4. If you consider n plus 2, then we have 3q plus 2. In this case, n plus 2 will be 3q plus 3, of which I can write as 3 times q plus 1. In this case, n plus 2 will be 3q plus 4. The same can be written as 3q plus 3 plus 1. Nothing but 3 times of q plus 1 added to 1. Observe, in these 3 formats, it is divisible only in this case, because it is multiple of 3. Now let us take n plus 4. In the first case, when r is equal to 0, what will be n plus 4? It is 3q plus 4. The same can be written as 3 times q plus 1 added to 1. When r is equal to 1, what will be n plus 4? It will be 3q plus 5. I can write this as 3 times q plus 1 added to 2. N plus 4 in r equal to 2, if we check it is 3q plus 6. The same I can write as 3 times q plus 2. Now you observe, only in this particular case we have multiple of 3. In this first one, it was multiple of 3. So we can conclude that 1 out of n plus 2 and n plus 4 is divisible by 3. For each case, we have to consider, when remainder is 0, only n is divisible by 3. When remainder is 1, n plus 2 is divisible by 3. When remainder is 2, n plus 4 is divisible by 3. So 1 and only 1 out of n plus 2, n plus 4 is divisible by 3. This complete answer is an answer for the second question. For the first question, this first part, when n value is considered, is sufficient. So here it is written, one of 3 consecutive positive integers is divisible, must be divisible by 3. Till this part, it's an answer for the third question, and the complete answer is an answer for the second question. Let us consider the fourth question. For any positive integer n, prove that n cube minus n is divisible by 6. N cube minus n is divisible by 6. What is this n cube minus n? It is same as n taken common, n square minus 1. This n square minus 1 is nothing but n plus 1 into n minus 1, using the identity a square minus b square. You look at this, is same as n minus 1 multiplied to n multiplied to n plus 1. These three are, what are they? Consecutive. In the previous question, we have seen, in question number 3, we have seen out of 3 consecutive numbers, one of them is divisible by 3. In the previous question, we have the result. The result was 1 out of 3 consecutive numbers. 3 consecutive numbers is divisible by 3. And we also have a result one out of every two consecutive numbers is divisible by 2. The reason is, when we consider 2 consecutive numbers, one will be odd number, other will be even number. Hence, even numbers are divisible by 2. So 1 out of every 2 consecutive numbers is divisible by 2. So we can conclude now, n cube minus n is divisible by 2 and 3, 2 into 3. That is, they are all divisible by 6. In the previous exercise, that is in the exercise 1.2, question number 2, we have already come across this question. This is a proof for that question. That was a short answer type, and this is a proof for that particular question. This is the last and important question of the exercise. Show that one and only one out of n plus 4, n plus 8, n plus 12 and n plus 16 is divisible by 5 when n is any positive integer. They have given the hint also. The hint is, any positive integer can be written in the form 5 cube plus 1, 5 cube plus 2, 5 cube plus 3 and 5 cube plus 4. Not to worry about this hint. Like the previous question, we shall apply division lemma by taking n and b value to be 5, which wherein there exist unique integers q and r such that they satisfy n equal to 5q plus r, where 0 less than or equal to r less than 5. That is, r can take the values 0, 1, 2, 3 and 4. For each of these reminders 0, 1, 2, 3 and 4, I need to find out only one out of n, n plus 4, n plus 8, n plus 4, 12, n plus 16 is divisible by 5. So I will make these many columns. Let me make some columns. In the first column, I'll consider when r value is 0. In the second column, I'll consider when r value is 1. In the third column, I'll consider when r value is 2. Then I'll consider when r value is 3. Finally, I'll consider when r value is 4. What will be the value of n when r value is 0? It is 5 cube. When r value is 1, n value is 5 cube plus 1. When r value is 2, n value is 5 cube plus 2. When r value is 3, n value is 5 cube plus 3. When r value is 4, n becomes 5 cube plus 4. That is for n. Now let us take n plus 4. Down below here I'll write n plus 4. N plus 4 when r value is 0 is 5 cube plus 4. N plus 4 when r value is 1, we have 5 cube plus 4. 4 or 5? It is 5 cube plus 5 because 4 plus 1 will be 5. N plus 4 in this case is 5 cube plus 6. N plus 4 in this case is 5 cube plus 7. N plus 4 in this case is 5 cube plus 8. That is for n plus 4. Now we have to take n plus 8. What will be n plus 8? For each remainder we need to find out. For remainder equal to 0, n plus 8 will become 5 cube plus 8. When remainder is 1, n plus 8 will become 5 cube plus 9. When remainder is 2, n plus 8 value becomes 5 cube plus 10. When n plus 8 for remainder equal to 3 will become 5 cube plus 11. N plus 8 when remainder is 4, it becomes 5 cube plus 12. That is for n plus 8. Now we have to consider n plus 12. What will be n plus 12 for each of those remainders? When remainder is 0, n plus 12 will be 5 cube plus 12. When remainder is 1, n plus 12 will be 5 cube plus 13. When remainder is 2, n plus 12 will be 5 cube plus 14. When remainder is 0, n plus 12 will be 5 cube plus 15. When remainder is 4, n plus 12 will become 5 cube plus 16. That is for n plus 12. Now we have to consider n plus 16. Let's take n plus 16. Find out for each of those remainders. When remainder is 0, n plus 16 will be 5 cube plus 16. When remainder is 1, n plus 16 will be 5 cube plus 17. N plus 16 for remainder 2 will be 5 cube plus 18. N plus 16 for remainder 3 will be 5q plus 19. Same way, n plus 16 for remainder 4 will be 5q plus 20. We need to observe in each of the columns exactly there is only one which is divisible by 5. Look at each of those columns. Let me highlight them. Here we have 5q, which is a multiple of 5. So look at in this row also, there is only one format. N is divisible by 5. Look at n plus 4. When remainder is 1, this particular thing is divisible by 5. The reason is we can take 5 common here. It becomes 5 times of q plus 1. Same way, when r is 2, in this case we have multiple of 5. When r is 3, in this case it is multiple of 2. When r is 4, in this case it is multiple of 5. The reason is 5q is a multiple of 5. 5q plus 5, same as 5 times q plus 1, multiple of 5. This 5q plus 10 is 5 times q plus 2. Since 5 is multiplied, it is divisible by 5. In this case, 5 common, we get q plus 3, it is divisible by 5. In this case, 5 taken common, we get q plus 4 is divisible by 5. Therefore, we can conclude one and only one out of n plus 4, n plus 8, n plus 12 and n plus 16 is divisible by 5. Students, I hope you people are writing the answers as well as the question by pausing the video, because these questions are considered to be important ones. Now I'll give some more questions which you can try. These are few important questions. For revision sake, I am giving you these questions. You can do this assignment separately. You can pause the video and note down these questions, or else screen capture it. Later on, you can write them separately, solve them, understand them. This will show whether you have really understood the concepts or not. Here I am giving some notes for revision. In this chapter, we had learned certain important concepts. I am giving them as key points. We had learned Euclid's division lemma, the application of Euclid's division algorithm in finding highest common factor. These things you can write it separately in your notebook. We had also learned fundamental theorem of arithmetic. We have revisited rational numbers if the denominator is purely of the form 2m, 2 to the power m into 5 to the power n, it is terminating. We have also revisited irrational numbers. We have proved certain irrational numbers as example root 2, root 3 and all. These are a few important questions. I have taken these questions from cbsaguide.com. These questions you can practice. Along with these questions, I am giving you the answers too. You can solve on your own, cross-check the answers. Still, the doubt pertains, you can ask when the school reopens. You can pause the video and note down these and practice them. I have collected some short answer type questions also, which are of 1 mark. Few of the long answer type questions also I have considered. These are the answers for those questions. You can solve those questions and cross-check your answers. If you get the same answer, that's the real happiness. I will be showing you some of the higher order thinking skill questions I have collected from different sources. You can note these questions along with the answer. Try to understand how it's been solved. Try to reason out why it is solved in that particular way. These are the questions. GCD always refers to highest common factor. Should not get confused. GCD and highest common factor both are same. We had solved some question of this type for finding the value of x and y, if you remember. This way of expressing with a different variable, x and y variable, is called as a linear combination. It's one of the questions which is repeated here. We had already solved this question. The exercise 1.4, we had this question. It was a third question in the exercise 1.4. this type of question also we had solved. It is also one of the very important question for the examination. This question 5, it was the objective type question. Remember, we had the same question. The least number that is divisible by all the numbers between 1 and 10, both inclusive. We had found the least common multiple. Yeah, this type of question we had solved, finding the value of x and y. It is also one of the very important questions. These were few important questions, and I can say that the first chapter, almost all important types of questions we have solved. Most of you must have downloaded the textbook from the website. Try solving those exercise questions with these videos which you have undergone, which you have seen. You will be able to solve almost all the questions. In case, if you have any doubt, you can just note them separately and ask. And all those questions which I gave as a revision, kindly solve it separately so that it will be of greater help during your revision for exam.